-1. Now, one last concept we have here is the idea of being closed. And this is kind of the book's definition here. It says closed. A set of numbers is said to be closed under an operation if the outcome of the operations with any two numbers in the set is also in the set. So good, I'm glad that's clear for you. I'm just kidding. So think about the set of natural numbers, what we're talking about. Natural numbers are numbers like 1, 2, 3, 4, 5, etc. on up from there. So I have put all those numbers in one room. So in that room are numbers like 1, 2, 17, 49, 100, etc., etc. There's a whole bunch of numbers in there. In fact, there's infinitely many numbers in there. So let's see if we can do an example and see if we stay in this room or if we can get out of that room. So our first question here is a set of natural numbers, the ones we just talked about, closed under addition? So in order to see if they're closed under addition, we're going to start grabbing two numbers in there to see when we add them together if the answer will also be in there. So let's say maybe 5 plus 3. Well, 5 plus 3 comes out to be 8. Is 8 in that room? Yes. 8 is still a natural number. What about 100 plus 50? That comes out to be 150. Is that still in that room? Yes, 150 is in that room. What about 10 plus 20? 10 plus 20 is 30. Again, still in that room. So as you notice, as I add any of these numbers together, I'm getting more numbers in that room. And if you think about it, if you keep adding any two positive numbers, you're going to get another positive number. So therefore, it's going to stay in that room. So then my answer for this is actually going to be yes. A set of natural numbers is closed under addition. Now, if for some reason it came out to be no, then we need to give a counter example, an example of why it's not closed, on how we could get out of that room. So let's move on to this next example here. Example 2, or this next example is not really example 2. It says it's a set of natural numbers, again, those same numbers that we're talking about, closed under subtraction. So now instead of using those addition signs like we were using earlier, we're going to be using subtraction signs. So let's see, maybe try some of those same ones. 5 minus 3. Well, 5 minus 3 is 2. Is 2 a natural number? Yes. Notice I even have it written up there. It's still in that room. What about 100 minus 50? Yes, 100 minus 50 is 50. So it still comes out to be in that same room. So far it kind of appears to be closed. But maybe if you think about it hard enough, or if you try enough examples, you'll find out that subtraction is not actually closed. Like try this next example that we did. 10 minus 20. Well, if I have 10 and I take away 20, now I'm actually going to have a negative number. This comes out to be negative 10. Is negative 10 a natural number? No. Natural numbers are 1, 2, 3, 4, 5, and they get bigger than that. So negative 10 is not a natural number. So the answer to this is no. Then we need to give a counter example. We could use this one that we wrote, that I just wrote, or you could pick up a different one. I'll use this one. 10 minus 20 is equal to negative 10. Negative 10 is not a natural number. So this whole thing here is my answer. So kind of in a sense, subtraction is that key that will unlock the door. Using subtraction, you can unlock the door and get out of that room of natural numbers. All right, good luck. Your homework starts on page 25. You can do all of them from have a 5 underneath it, all of them have a 4 underneath it, and then 4 more of your choice. I believe it's just a total of 15 homework problems. Enjoy, good luck. Again, watch it if you need to. Ask questions tomorrow in class. I'll be happy to help you.